Hi, scientists. So, welcome back, and I just want to do a quick reminder that we've been talking about the three states of matter, and yesterday our focus was on solids. So, I wanted to show you what I added to my notebook. So, I did sketches of the three solids that I found in my home, and I labeled size, what they were made of, if they were soft or flexible or rigid and hard, and then I added on that statement of when energy is added to a solid, it will turn into another form, keeping in mind that this is coming later in our week. All right, so today we're going to focus on liquids. And so I have the next poem in our three states of matter, and it goes like this. Liquids. A liquid moves smoothly. We say that it flows from one place to another. How quickly it goes. We know that most liquids are easy to see with no shape of their own. They're not like you and me. Okay? So be thinking about that because today we are going to talk about a few things about flow when we're talking about liquids. And I want you to go ahead and turn to your notebooks and get to the part about our liquids. So get to your liquids page. And here's my liquids page, and you're going to notice a few things added in bright pink. But first, I just want to highlight the things that we already learned about liquids. One of them is that it takes on the shape of the container that it's in. It does not have a form of its own. Also, that atoms are close, but they can move around, and they move around with a higher energy than those of a solid. Liquids flow from a high level to a lower level. And again, I said that we were going to talk a little bit about this word flow. So I want to introduce these words to you. Viscous, you say viscous. And viscosity, you say viscosity. And what this means, and I'm going to focus on the word viscosity, is the rate at which liquids flow. And if something has a high viscosity or very viscous, it will flow slow. So say high viscosity, the slower the flow. And that's what we want to remember. If it has a low viscosity, the faster it flows. Okay? Also, I want to highlight, because this is going to come later, just like with the solids, that I am going to be adding into my notes when energy is added or slowed down, liquids will turn into another form. So keeping that in mind. So today's challenge is for you to find 3 liquids in your home and then sketch them into your notebook and label them. And I would like for you to think about what we just talked about with viscosity. And if their flow is slow, then I want you to remember that that means that they have a high viscosity. If their flow is quick, then I want you to remember that's a low viscosity, okay? So the first thing I wanted to share is that, and this is probably many of you thought of too, but I have this water bottle. And in here, I wanted to just show you how this water has taken on the shape of its container. If I were to take it out of this container, it would not stay this shape, right? The other thing I wanted to highlight is to show you how it will flow from the high level to a lower level. So if I tilt this bottle, you can see this is the lower level, and there all the water pools. Okay, so keep that in mind. Also, would you say this is viscous? Is it very slow, or does it flow quickly? Right, it flows quickly. So water has a low viscosity because it flows quickly. The next one I wanted to share with you is something that we're all using quite a bit of, I imagine, but this is liquid hand soap. And I want you to notice the flow. It's going to the lower level. It went from the high level to the lower level, but much slower than the water. And I don't even know if you can see that, but that little bubble is kind of coming up in there. And this is viscous. This has some viscosity to it. So we would say that this has a higher viscosity than water because it flows slower. Okay? And then the last one that I found, and I actually put it into this glass because I wanted to show you how it took on the shape of this glass and it became round. What I poured it out of was a shampoo bottle. And so it was the shape of the shampoo bottle until I poured it into this glass. And I want you to watch the viscosity in this and tell me, do you think this is higher or lower than the hand soap in the water? Okay, and look even how long it stays up on the glass to come back down. If you are thinking that this has a high viscosity, you're right, because the higher the viscosity, the slower the flow. All right, you guys, I will be sketching the things that I shared, the liquids I shared into my book, and adding the word at least viscosity into my journal, as well as this idea of the change in energy to liquids. You too, go find 3 different liquids and please label whether or not they are high viscosity or low viscosity and how you know. Good luck. Bye.